All right, this week it's all about functions, but this time it's custom functions. Now you've already been working with functions. We've worked with the print function, the input function, the format function, but now we're going to learn how to write our own custom functions, functions that we design for a particular purpose. And it's an important concept in programming, and all computer programs consist of functions, not just the main function. Here's why it's a good idea to modularize a program with functions. What you don't want to have is a long main method with maybe hundreds or thousands of lines in it. Instead, you try to keep the main function as small or short as possible, and instead create blocks of code elsewhere in your application called functions that you can execute as required from the main function. And it gives you these examples. It's actually just simpler. It's easier to understand. It allows for reuse. Python programmers and programmers in all programming languages, once they work out a function and get it all debugged and tricked out so that they know it's working properly, they will store it because they might need it again in the future. And that's a really good thing that all programmers do. It allows testing to be a little bit easier. If you break down your code into functions, you can focus in on where the problem is by looking at the function as opposed to searching through the entire main function. It allows for faster development, teams of programmers. It facilitates teamwork. Just consider for a moment the video games that I know you mostly play, almost all of you. I suppose you probably all play games. Well, if you look at the credits for those games, there are dozens of people listed that work on those games. And now some of them are story developers and graphics experts and so on, but there are a lot of coders that work on those games, and they break down the task into certain functions. Like some of the coders are responsible for the sprites, things that move around the screen. Some of them are responsible for the background. They break it all down, break the job up into multiple functions. And that's what we're going to look at today. So what I thought we would do is just do a few examples. I think the best way to learn this is to do a few examples. And I've got some ready here for tonight to try. Here they are. I've got four examples that I'd like to work through, and we can work through these together. Okay, I'm going to suggest that we work through these together. You might want to code right along with me as we work these out, or actually I'm going to prompt you for as much of the code as possible as we try these. So let's look at this first one here. We want to write a custom function that takes an integer and a string. Now, when we say takes, that means we're going to pass an integer and a string to the function so that the function can work with those. And what we want this function to do is print the string the number of times as indicated by the integer. I'm not sure if that's very good grammar right there, but I hope you get the idea. So I'm going to fire up my idle here, and let's give this a try. That's another program I was working on earlier. So I'll first bring up the new file. All right, let's see if we can write that program. And I'll see if I can keep it on the screen so we can see what the problem was. Okay, there's what we're trying to do, that first one. Let's see if we can write that function. So I'm going to call this example1.py. And I'm going to def main because we will be using main. But what we want right away is to define that other function. So let's concentrate on that right now. We're going to make our own custom function. And we do that with def as well. Now, first thing we have to do is decide on a name for the function. We should name it something that indicates its function. And in this case, what would you like to try here? What do you think might be a good name for this function? It's a function that takes an integer and a string and prints that string a certain number of times as indicated by the integer. Not sure? Well, I'm going to go with repeat string. I'll just call it repeat str. That's what we want to do, right? We want to repeat the string. Now, we open a set of parentheses just like we do with main. And now we want to specify an integer and a string. So I'm going to go with, how about num?
The word, comma, number. That's
right. That's right. Yeah, it wouldn't matter what order we put them in. That will matter when we go to use it. But you're right. I'll put, yeah, word. I like word. Word is good. Okay. We call these the parameters. When we're defining a function, sometimes the function needs some data to work with internally. And this is a good example. This function needs to know the integer and the string. And so we have to give it these two values to work with. Those are called the parameters of the function. So now let's see what we want to do here. We want to print that string a number of times as specified by num. Repeat. Repeat should make us think of a particular type of structure that we could use. Anybody have an idea on that?
Leave it.
Sorry?
I'm not sure what you're asking.
What?
Yeah,
A loop?
A loop. I think that's what we need here. I think we need a loop, right? If we want to repeat the string a certain number of times, we could use a loop to do that. So I'm going to go for a for loop. How about for? I typically use n to represent a number. How about for n? But you could use any variable. For n in range. Now, what are we going to put inside the parentheses of the range here?
So how many do you want it? So either a range or just the number plus one more that you want.
Okay. Very good. Very good. Very good. Now, in this particular case, we are inside this function called repeat string. What's the
you would put
name of that number?
Do we do 1 to num?
Or would it just be num?
We could do either. We could do either. I think just num will do. Just num will do. Because remember, if num is 5, this is going to run 5 times. And now you're quite right in understanding that the values of num are going to go from 0 to 4, but it will run 5 times if num is 5. So I think this is good. I think this is what we want. Now, what do we want to do inside this loop? Anybody? According to the instructions up above?
You want a word.
That's right. We want to print the word. Okay. So I think that might do it. Let's hope so. We'll find out if that's going to work. Now, this is just the definition of the function. This does not run, just like main doesn't run until you type main down here. And by the way, I'm going to do that right away because I often forget.
Don't we have to specify num and word as well somewhere later?
Inside main. Yes, we're going to run this from main. This is just the definition of the function here.
Okay.
What we're going to do now in main is we're going to use that function. We're going to call the function is the term that's used in computer programming. When you execute the function, the term call is used. We're going to execute or call the function. So what we could do here is we could make this an interactive program. That would make it a kind of a nice program. But just as a really quick and dirty example here, I'm going to try just entering values in hard code. I'm just going to hard code them in. So I'm going to go with number equals 10 and name equals Guido. Okay, so there's a number and there's a string. So let's see what happens when we execute or call the function. I'll put a little comment in here.
Would we not have to call it num and word?
No, which is interesting. No, we don't have to do that. It's a good point that we will cover. But to call the function, I'll use its name, repeat string, just like you call the print function, you type in print, right? Well, this function is called repeat string. Now I have to give it two values to work with. And according to the way I've defined the function down here, I have to give it the number first and then the string. So in this case, I would give it number and name. That should call the function. Now we know number is 10 and name is Guido up here. When we run the function here, here's what happens. Python reads this code and then it sees this line here and it says to itself, hey, I got to run this function called repeat string and I'm supposed to pass these values to it. Well, when that happens, Python finds the code down here with the same function name, and it lets num be the value that we put into number here. It lets word be the value that we put into name here. So the number gets passed into num, the name becomes the value of word here. These are called the arguments. When we actually run the function, what you put inside the parentheses are called the arguments to the function. The argument values they go into the parameter values. That's a really important concept. So I just want to run this one and see if this thing works here. So I'm going to press the F5 function key. And of course I have to save it. I'll save it as example 1. And I do have on my desktop, I do have a folder set up here called PyFunks. And I'm going to save it as exercise 1. I don't want capitals there though. I always worry that my dog's going to start barking. But she's sleeping on the bed here. I have a beagle, pretty laid back. Okay, I'm gonna go with a new window here. Try this over again. Okay, here we go. We'll run it one more time. So we got Guido 10 times. If you count them up there, that's 10 times we got Guido. So this function is working. It's doing what we asked it to do, which is not very complicated really, but what we asked it to do was print the name Guido 10 times, because this has a value of 10, this has a value of Guido. When we run the function, the value 10 goes into this variable, which we call the parameter. The value Guido goes into this variable, which is the second parameter. And then we use that down here. Now what's interesting is the number variable is not visible down here, and the num and word variables are not visible up here. If I were to put up here print, I'll try it, I'll just say print word, which is a variable that we have down here. This program will crash after it prints out the names. Let's just try it one more time here. Yeah, you can see it blows up after it does its job, because it can't print the value of word. Word is not visible. Let's see if I can scroll it up and show you that here. I don't know if you can see it at the very bottom of my screen. It says word is not defined. Word is not visible. The term we use for that in programming is the word local. It's not in scope. Yeah, that's right. It's not local to. It's not local to main, or it's not in scope in main. The word and the num, these variables, which we call parameters, they're only visible inside this function. They're not visible up here. Likewise, these variables, they're not visible inside this function. Variables are only visible inside the function in which they are declared or passed into as parameters. And that's a very important point. It's called scope of variables. Any variable that's declared inside of a function is said to be local to that function. So these are two local variables here. They're local to main because they're only visible in main. Now I could run this. Obviously, I'm going to take this. I'll comment this line out since it's going to crash the program. But I could actually run that repeat string program function, I should say. I could run that again, and I could just put in actual literal values instead of using variables. I could use like 6 and how about Tampa? That's a string. That should work too. Let's try it. I'm going to go for a new output window though. I'll kill this window off. It's getting a little too busy. Okay, here we go. And there's the last part of it. 6 times we got Tampa. So now we know that we've got a function that works. This function will always print whatever string we give it, and whatever integer we give it, it'll always print that string that number of times. So, any questions about that one? The first time you see functions, it can be difficult, but it's extremely important, and it's something that all computer programmers have to do in every programming language. Any questions? Let's see if you've got a chat window going here. You feel free to ask questions in the chat window if you don't want to turn on your sound. Question, Todd? Okay.
No, I'm just trying to wrap my head around what you just did.
Okay. Well, feel free to ask a question about anything that's fuzzy because I'd like to try and reword it.
So you can put repeat string as many times and under when you call it, like you got 2 different repeat strings here. You can put as many repeat strings as you want with different variables in there, I guess. Or
right. Different. We call these arguments. Right.
Arguments. I meant yes.
Yeah.
Okay.
In this case, I'm using variables for the arguments. In this case, I'm using literal values for the arguments. Normally, it's going to be variables.
So since you did the literal, you would be able to delete the stuff you did up top with the equals, the 10 and the Guido.
Oh yeah, if I didn't want to see that, I would just comment it. Yeah, I could just comment this out.
So what's making the program ignore the variables and go in with the arguments?
Not quite following exactly what you mean by ignore.
So when you ran it, we saw Tampa printed 6 times, right? We didn't see Guido printed 10 times and then Tampa 6 times, or do we?
Oh, yeah, there it is. There's Guido.
Oh, okay. I'm sorry. I thought that was part of the first time you ran it. Okay, never mind.
Okay.
Never mind. Question
We got them both. Yeah.
Okay.
I could comment this out, of course, if we only wanted to see the Tampa output.
And you can also use it you could make these 2 inputs.
That's probably the best way of all. So let's do just that. So what I'm going to do is I'll comment all of these out. I can do that with format comment out region. That'll comment every one of those lines out. It's a nice thing you have on the menu there. So why don't we do this totally with inputs from the keyboard? So why don't we go with, say, we can continue to call it number, but we don't have to. We could call it any variable we want. And let's int input. So let's get a value from the user for the integer. So we'll say enter an integer. And then we'll ask the user to enter a string. I'll call that strng equals. Now remember, for a string, all we need is input, right? Don't need any function. We don't have to embed it at all. So now we could say enter a string. That string could be anything. It doesn't have to be just a name. It could be a sentence or whatever. And now we'll execute the function. So we'll call the function again with repeat string. And we have to get them in the right order. We have to put the number first, followed by the string, because that's the way we define the function here. Number first, then the string. So in this case, it's going to be number and string. Let's try it. I'll kill this window. We'll try it in a new window. Okay, I don't know what you want to try. We could try 15. And why don't we try Python rocks my world. There it is, 15 times. So that's by far the best version of the program, I think, using inputs from the keyboard. Everybody okay with how that works?
Yeah.
Any questions? It's kind of strange the first time you see it. Here, I'll just go over the concept again quickly. The idea is you define your function, use the def keyword, give it a name. If the function requires some parameters, that is, if it requires some variables to work with internally, then you put those inside the parentheses. Then you code whatever you want to have done with those parameters inside the function. That's got to be tabbed in, of course, got to be indented for that to work, or else it's going to crash on you. So that's just the definition of the function. This doesn't run until we make it run. We make it run right here. There's where we make it run. Just like this is where we make main run down here, right? Mm-hmm. So in this case, we're asking the user to enter the two values from the keyboard, and then we're calling them here. Now, here we call these variables arguments. When you run the function, actually use the function, usually in main, but not necessarily. You could call a function from any other function. But when you run the function, these values are called arguments. And the number argument gets passed into the num parameter. The string argument gets passed into the word parameter.
Can you use this concept to call up other files?
Yes, we can read files with this. Chapter 6 in our book handles that, actually. And we'll be doing that next. We'll be looking at files and how we can read files, and we'll be writing functions to read files in chapter 6.
Okay.
Yeah, that's the thing about computer programming. If you kind of think of something like, I wonder if we could do this, the answer is almost always yes. Yes, there's usually some way to do almost anything you can think of, which is one of the things I find intriguing and fascinating about programming myself. Well, if you're okay with this one, I'm going to leave it and move on to the next one. Okay? So I'm going to leave this one. Any question at all? Okay, we're good. We're good. All right, well, let's look at the second problem here. Let's write a custom function that returns the larger of two numbers. Now, one thing I didn't point out about this function here, this is what we call a void function. It prints something. It doesn't return a value. Some functions return a value back to the function that called the function. Actually, the input function is a good example. Take a look at this. This is a function call right here. It's one of the functions that's built into Python called input. And when we enter a string, it actually returns the value that we type into this variable here. So it's called a value returning function. Input is a good example of it. So is the int function. The int function takes a string, converts it into an integer, and returns its value so we can catch it in another variable. Well, this next function we're going to work on, this next example here, this one is going to return the larger of two numbers. So let's see how we might code that.
Can I ask a quick question on the difference between void and return function?
Yeah.
So if I understand correctly, the void function, it's executed in the main function, but the return value function not only needs to be executed, but the result it's needed for main to run?
Not exactly. I maybe you didn't say exactly what you're thinking of there, but based on what you said, I would have to say not exactly. The thing that differentiates a void function from a value returning function is there's no return statement here. This function has no return statement. That means it's doing its job, but it's not tossing anything back to the function that called it. Whereas here, this function is doing its job and returning a value back into this variable here. Now, what we're going to work on in this example here is we're going to return the larger of two numbers. So let's start on that, and I think it might answer your question. So what I'm going to do is I'm just going to clear this out, and I'm going to get rid of this one. We're going to need def something or other here, though. So it's going to be something like this, and I'll call it example 2. I'll save it right away with that new name. I guess it's exercise 2. Not exercise. Okay, so we'll save it with that new name. Yeah, I guess I put the wrong name in the last one. Okay, now let's define this function, the custom function that returns the larger of two numbers. What would you like to call that function? Something that's based on what it does. Anybody have a good suggestion there?
Larger of 2.
Yeah, okay. Okay. Larger.
Underscores.
Okay. Yeah, you could say larger of 2. Like this.
I'm very pragmatic.
That would work. That would work. You could call it, you could just call it max or larger if you wanted to keep it simple, but this is okay. I'll go with it. Now, does this function require any parameters to do its job? Does it need any data to do its job? Yeah, exactly. It has to have the two numbers, right? If we're going to have this function determine and return the larger of two numbers, well, it needs to know what the numbers are. And so we need two parameters. I'm going to call them num1 and num2. Those are the parameters. Now, how will we determine the larger of the two?
So I did something similar, and I know I did this wrong for the prep work, but basically I took the two numbers. So I took num1 minus num2, and then I evaluated with if and elif statements.
That's what we need. Exactly. We need if and else here, don't we?
Okay. So
You're right.
The first thing I did was I called greater number my variable, and I did num1 minus num2.
Okay.
And then I said if greater number was bigger than 0, I also want to, well, never mind because I was doing that for the prep, but if my greater number is greater than 0, then I will print num2 is greater than num1. And then I did elif the greater number is greater than 0, then my 1 it's greater than 2. Else I will say, they're equal.
You know what? I think your logic is pretty good. I think that could work. I do think that there's a slightly easier way, though.
Okay.
What about if num1 is greater than num2? If that's true, what's the larger?
Oh, because the program knows.
Oh, that was
It
so
understands,
simple.
right?
It's a little bit easier, right, Val?
I made it do the math.
I will too.
But your logic was good. Your logic was good. See, this function knows what num1 and num2 are. And so we can use a simple if like this. If num1 is greater than num2, well, which one is larger? Tell me, anybody? If this is true.
Num1.
Yeah, num1. And so here's what we do. Remember, what we want to do is return the larger. So here, all we have to do is say return num1. And that'll toss it back to the main function. Now, if it's not the larger, what is the larger?
Return num2.
Exactly. So we would return num2.
See, like Val, I forgot that the program already knows how to do all this stuff. I would have done the same thing she said.
Oh, yeah.
Well, no, the program doesn't know how to do anything.
It knows something's greater than the other.
Well, but it doesn't until we put this line in. Yeah, not until we put that line in there. We gotta make our if condition. So this is chapter 3 stuff, right? Find the larger of two numbers. But here's the kicker, though, right here. We can return the value back to main. Let's try to work this thing in main. So what I'll do, just something like what we did in the last one. I'll use some literal values first. Let's call this function. So we'll call the function. And I'm going to call it with just some literal values. Well, I call it by name, larger of 2. And I have to give it 2 arguments to work with. So I'm going to go with 12 and 10, which obviously we know what the larger is. But at this point, the program actually doesn't know. So that's the function call. I'm going to run it just like that. Let's see what it runs like. Okay, here we go. I'm going to give it a run right now. Oh. Do I have my main down here? Yeah, I just wanted to make sure I have my main. Okay, here we go. No output. It worked. It didn't crash, but we got no output. So this did work.
Do we have to tell it to print something?
Yeah, we would have to tell it to print something, but most importantly, we have to catch the value that's returned. See, this function is returning something. It's returning either num1 or num2. When we call this function, we have to let it assign a value. So we have to do something like this. That catches the return value in the variable called number. Then we can print out that it's the larger. So we could then say print
number.
Yeah.
Okay.
So something like that should work. Let's try that again. Run it one more time. Right, 12 is larger, which of course we know is. Now I was just using literal values. Normally we would use variables here for these arguments, as we should call them at that point. But as you can see, it does work. But here's the kicker. We got to catch that return value. If you don't catch that return value, it's like playing catch with somebody and they throw the ball over your head. You don't get to play with it. Well, we want to use this number line here. So we have to catch the return value in this variable. And that's always the case with a value returning function. If the function returns a value, you got to catch it or there's no point of returning it. Does that make sense? It's kind of a weird concept, perhaps. First time you see it. Now, we're not using keyboard input here, but we could. What I'll try is I'll just let N1 be 15 instead of using keyboard input and say N2 equals 13, say. Okay, now I'll try running the function again. Only this time I'm going to run it in a slightly different way. I'm going to embed the function call in the function. This is done. The larger is in my string. Now I'm going to call the larger of 2 function right here. Larger of 2. And give it those variables to work with, N1 and N2. And then closing parentheses, 1 to close the larger of 2, 1 to close the print function. What we're doing here is we're embedding the function call inside of the print function. And because this returns a value, soon as the Python program gets to this line here, it says to itself, self, you've got to go find the function called larger of 2 and use these two values here. It finds this code down here, determines which one is larger, and returns it. So the number that it returns goes into this position and then gets printed out. So when we run it, it looks like this, which of course is 15, as we know. So we embedded the custom function inside the print function. But wait a minute, that's not such a new idea. We did that with the format function, right? We embedded the format function inside the print function. Well, this is just our custom function that we're embedding inside print. Now, we could redo this with keyboard input, but I hope you get the idea. The main thing is, if the function returns a value, you've got to catch it. Either catch it in a variable that you can use later, like sometimes you catch it in a variable and you want to do more, maybe more math with that number. In this case, we just wanted to print it out. But the other option, if you don't catch it in a variable, you could use it as the embedded argument to a print, for example, or some other function, perhaps. I'm sure you have some questions about this one, and please feel free to ask. I'll try to make it more clear. Anybody?
Actually makes sense.
Okay, good. Now we're returning a number. We could return strings. You know, I mean, we could return strings. We could return booleans, like we could return true or false if we wanted. It's up to you, whatever the program requires, whatever the function is supposed to do. Well, if you're okay with that, I'm going to move on to. I think what we'll do is I think I'll try this one next, this last one. If we have time, we'll come back to number 3. But I definitely want to get to number 4 because we're going to make a module. We're going to write 2 functions for rectangles, 2 of them this time. Both of them should take the length and width as arguments. Those are the key measurements, of course, for a rectangle. One function should return the area. The other should print. I've got a word "the" in there that I don't need. Should print both the perimeter and the length of the diagonal. And what we want to do is we want to use the math module to determine the diagonal's length. The math module. Well, that brings to mind the textbook, and we do have the math module. I believe it's on page 263 in this chapter. 26. When you start working with Python, you've got a number of functions that are available to you. We've learned that print is available, input is available, format is available, but there are all kinds of other families of functions that have been stored in files called modules. And there are literally hundreds of them that have been made by Python programmers that came after Guido and wanted to share work that they had done with their fellow programmers. It's just a wonderful thing that Python programmers do. So we've got, for example, a module called the math module. And the math module has all kinds of mathematical functions built into it. As you can see, we've got some trigonometry functions up here at the top. We've got some functions that can determine the logarithms, natural logarithms, square root function. We've got a floor function, which will basically round down a number that's got decimals in it. It'll round it down to the next lowest integer value. And it has a counterpart called ceil, which goes the opposite way. But there are just all kinds of these functions that are in the math module. But to make them available to you, you have to import the math module. You have to import it. I just got kicked out for inactivity. It'll let me back in. Okay. I didn't know I had a time limit on that. Okay, so this is available to you, but in order to make it available in your program, you have to import it. And let's see, here's an example right here. I don't know if you can see that line. Import math. That makes all of the functions that are in the math module available to you in your program. So let's see if we can tackle the problem that we had set up there. Let's see if we can tackle this last problem. We're going to write two functions for rectangles. One, both should take the length and the width. One should return the area. Notice that keyword there. And the other should print both the perimeter and the length of the diagonal. So it's not going to return anything. So I guess it's just going to have a couple of print statements in it. And what we want to do is we want to use the math module to determine the diagonal's length. Okay, so let's give that a try. So I'm going to clear out this. And we don't want this function anymore, but we want two others. I'm going to call this one, I guess I'll call it exercise 4. And we want to define two functions. First one should return the area. Both should take the length and the width as arguments. So I think a good functional name for this one would be area. You could say return area if you wanted. But let's just go with area. Now, this function is going to need two values to work with, the length and the width. I try to use len, but len, you notice it shows up in magenta. That means it's part of the language. It's a built-in function in Python, so I can't use that. So I could go all the way to length, and width should be okay too. Okay, so we have to give this function both the length and the width. Now what we want to do is return the area. We should be able to do that with a single line.
Import.
Well, we don't really need to import anything to work out the area of a rectangle here.
Oh, I mean length times width.
That's right. And now what do we want to do with that length times width?
We want to return.
Exactly. Return length times width. That's all we need in this particular function. Now, it wouldn't be wrong to say area equals length times width, return area, but why use two lines if you don't have to? This is by far the easiest way to do that function. So I think we've got that one covered. Now we want to write a second function that should print both the perimeter and the length of the diagonal. So what are we going to call that one? I'm going to go with Perry diag.
Diag.
Kind of a pathetic name, but we'll go with it. We could just call it rectangle info or something like that too, I suppose. But once again, we're going to need both the length and the width. According to the instructions there, it's supposed to take both functions are supposed to take the length and the width as arguments. Now, right now we're specifying these are parameters at this point. Now let's determine the perimeter and print it out. We could call it Perry, short form for perimeter. What's the formula for a perimeter of a rectangle? Anybody?
2 times length plus width, right?
That's outstanding. 2 times length plus width. Would that do it? Actually, no, right? This isn't quite right. Because this is only going to multiply it 2 times the length. As you know, it's 2 times the length and the width added together first before you multiply by 2, right? So we need parentheses here to make this valid. That should work okay for the perimeter. Now, we also want to get the length of the diagonal. Okay, somebody just rejoining us here.
My internet went out.
Okay. We want to get the length of the diagonal. Let's go back, take a look back at that math module again for a second. Hey, look at this one here. Hypot xy returns the length of the hypotenuse for sides x and y. So this should calculate the hypotenuse. Well, that's what the diagonal is, isn't it? The diagonal is the hypotenuse of the right angled triangle that's made by the sides of the rectangle. So we should be able to calculate the diagonal. What do we call it? Diag equals. Now, I have to use the math module. So I have to import math. So I'm going to do that up here. I'll say import math right up here. That'll make all of the functions that were defined in the math module available to our program. But in order to use them, I have to preface the name of the particular function that I want, hypot, with the name of the math module. And now inside the parentheses, I'm going to put my length and width variable. So that should calculate the diagonal. Math.hypot. There is a little trick that you can do that I sometimes show in my classes too, that you can say import math as m, and then you can shorten up your code and just say m.hypot. You can give it the math module an alias name like this, and that's a cool thing that you can do. It's not required, but it's kind of cool, so I'm going to do it. Now, what I have to do is print out both of these. According to the instructions in the problem here, we want to print the perimeter and the length of that diagonal. Okay, so I just need two print statements here. So we could say perimeter is peri, and then we could also print out what the diagonal is. Diagonal length is. Now this one could get kind of ugly because it's most likely that the it's going to have some decimal places in it, right? We don't want to see like a whole bunch of decimal places across the screen when we run this one. So I'm going to use the format function here on this one. We'll format our diag variable, and what we'll do is we'll format it to show how about 2 decimal places. So we'll put 0.2f here. And I think that should do it. Okay, so this particular function is doing 2 things. It's going to calculate and print the perimeter and the diagonal length using the math module for the diagonal length. Now let's run this thing up in main. I've got 2 functions I could run, the area function and the length function. The area function returns a value. I'm going to catch the value in a print statement. So that's, I think, the most elegant way, unless I want to do some work with the that value. So I'm going to go with the area is, now we call the function area, but wait, what with? I'm going to go with some literal values. I'll go with 12 as the length and 5 as the width. Okay, we'll try a 12 by 5 rectangle. And you know what? I think I'd rather do this with variables. So I'm going to go with this is a very bad variable name. I'll just make it really short though. I'll go with LG equals 12, width equals 5, so that I can use variables here instead of literal values. So LG is supposed to be the length and width for the width. So that should call that function. Now let's run the other function. Now to run the other function, it's a void function. It doesn't return a value. So I just have to call it by its name here, peri diag, and give it the 2 values to work with, LG and width. And that should work. Let's give it a try. I have to save this as exercise 4. I don't want to overwrite that previous one. So save as exercise 4. And we'll run it. I'll get a new window though before we run it. So here we go. Area works out to be 60. Perimeter is 34. That would be correct. 12 plus 15 is 17. Multiplied by 2 is 34. So it looks like the math is working out okay. For the diagonal length, 13. 13 is correct. As it happens, 5, 12, and 13 perfectly make a right-angled triangle. It's what you call a Pythagorean triplet, 5, 12, and 13. And I chose that specifically so that this would work out exactly. But this could work with any length and any width at all. And that's the beauty of creating your own functions. Now we know that these functions work. Okay. Any questions about this one? We did quite a lot in this one, but notice when you call the void function, you don't have to catch any return value. You don't have to worry about that. You just call it by its name. But the area function, because it returns a value, I either have to embed it inside a print or assign its return value to a variable, which I could then print later. Now, there's one more thing I'd kind of like to do. These two functions right here, we could make our own custom module. And we do want you to do this for your assignment. So I'm going to copy those functions right there. And I'm going to create an entirely new file. And just get rid of all these. And I'm going to create a new file. And I'm going to call this my rectangle.py, and this is going to be my custom module for rectangles. And what I'll do is I'll paste in those two methods that we just copied. I just copied out of that last program. So this is what a module is. I'll have to save this as rectangle.py. Okay, there it is, rectangle.py. And it contains these functions that we know work. Programmers do this all the time in Python. Once you get some functions that you know you've debugged and that they're working properly, store them in a module so that you can use these in the future. I could use these 2 months from now by importing the rectangle module into my program. I would have access to these functions that I've already worked out. We don't want to reinvent the wheel when we're programmers. We want to save our work that we know is debugged and use it in the future. Now, how do we use this? I want to go back to that program. So I'm going to open up that exercise 4 again.
You'd call it up the same way you did the math, would you not?
Kind of, yes, very much so. Yep, very good. Here it is. And what I'm going to do here is, instead of importing math, I'm going to import rectangles. And then I'm also going to import math. I'll try importing it here. I could also import it inside the module, but I'll import it here as well. So you can import more than one module. And as you can see, I am doing that here. But notice that when I imported it, by the way, it's called rectangle, not rectangles. So I got to make sure I get the name right. And I don't put the .py in, just the name before the .py when I go to import it. So I'm going to import rectangle. And now I want to use it down here. Well, since I've imported it, see, I don't need these. They're available to me because I've done the import. All I need down here is to call my main function. But in order to use these, I have to say rectangle.area. Now maybe I can make this easier if I say import that as R, and then I could say here r dot area, and here r dot peridiag. Let's see if that works. I'm going to give it a try. I'm going to save it as 4b. File, save as, and we'll call this one 4b since it's a variation, and give it a try. Mine crashed right away because of the M. M is not defined. So I forgot that I used an alias for M for the math module there. So we'll fix that problem right away and try running it again. Crashed again. Name M is not defined. Did I not say that? I thought I did. Let's run it one more time.
Wouldn't that be in your module that needs to be saved?
That's where it needs to be. Yeah, thank you. Thank you very much. That's where it needs to be. So I'm going to take it out of here. Just completely remove it from here. And I'll put it inside the module file called rectangle. So we'll open it up again. Here it is. And I've spelled module wrong up here, I see. So what we will do here is we'll import math here. Now, we would have to say as M, since that's the way we're trying to use it down here. Okay, so we'll save that. And we'll try this one more time. And this time it works fine. So we used our custom module called rectangle. We made our custom module. We're now developing into real, genuine programmers.
And there was nothing special about the path that you took to save the module, right? You just did save as, named your file, and that was it.
I did make sure that I put them in the same folder so that they would be accessible. Okay. Yeah, that's important. So when you submit your work, you want to put the module file, there it is there, rectangle. You want to put it in the same folder as your program.
Okay.
Well, that's about all I wanted to cover with you. There's one more thing that we didn't get to cover, and that's random numbers, which is, it's explained reasonably well in the textbook. Most of the time, all we want you to generate is a random integer.
Okay, that was actually the only question I had left, just looking at the prep. But I understand we don't have time, so I'll go look in the book. But just to make sure, on the first exercise for the prep, and just so I understand the semantics correctly, I'm not looking for a hard code input. I'm not looking for a user input. I just need to generate a random number between 1 and 5.
Right here, right?
Yes.
This one here?
That one.
Yeah. Let's see what it says here. It says, in the main function, generate 2 random integers in the range from 1 to 5. Okay. And then call the show larger function. Okay. Well, here's how you do that. You have to import random. And I'll import it as R. Now, as you can see, I'm just working in the interactive window here, but this would work equally well inside the program. Now I should be able to say num equals r dot rand int is the function that you want for a random integer. Now, if I want a random integer from 1 to 5, I make that 1, 5. You don't have to make this 6 like you would have to do with the range function. And that should, if I print num here, we should see that it's a number from 1 to 5.
Oh, perfect. Okay.
I could repeat this over and over again here. Oops, I thought I ran this line here, but I guess I didn't. Got a 1 that time. Every time we run it, we should get something between 1 and 5. So if you want a number from 1 to 100, you'd make this 1 and this one 100.
All right, perfect. Thank you so much.
Okay. All right, folks, I guess we're out of time. Thank you. I hope this will help you with your assignment. I think it will. Functions are extremely important. Make sure you cover the textbook. By the way, I neglected to point out that it's really important when you start a module, like in this case, module 5, that you go through all of the content that we have here. There's all kinds of learning instructional material here that you should try. Okay, something wrong with this last link here. I'll have to fix that. But right here, we have a lot of things that you can look at that are very similar to what we did tonight, but they'll reinforce what we did tonight. So you want to look at those. Okay, this has been recorded. I will toss this into the links and resources section of our course. Go back to the table of contents. Each week after our session, I'm putting the recording as soon as it finishes processing. As you see right now, I'm waiting for my courses. I'm watching the spinning thing up here, patiently waiting for my courses. But at the bottom of the table of contents, you'll see links and resources, and I'm tossing them in there each week so you can review them if you want. There we go, links and resources. So as soon as it's available, I'll make this available on YouTube. That's last week's right there. All righty.
Thank you.
Thank
Thanks
you.
very much.
Have a good night.
All right, thank you.
Keep in touch. Brad out.